There are a few things throughout Regents chemistry that you will have to memorize, and this is one of them. And that is that each principal energy level is divided into sublevels. Those sublevels consist of S, P, D, and F. And those letters actually correspond to different shapes. Those sublevels are also divided into orbitals, and each orbital can hold 2 electrons. So we're going to figure out how many electrons can be held total in each sublevel. The S sublevel only has 1 orbital. And as I just said, each orbital can hold 2 electrons. Since there's only 1, it would hold 2 electrons. The P sublevel has 3 orbitals, or 3 orientations of its shape, and each orbital holding 2 electrons means that it can hold a total of 6. The D sublevel has 5 orbitals, or 5 orientations of its shape, and each one can actually hold 2 electrons for a total of 10. And F has 7 orbitals, each one holding 2 electrons, for a possible total of 14. Now, each principal energy level doesn't have all of those sublevels. If you think of principal energy levels, here's the nucleus, as kind of the rings around the nucleus in the Bohr model. The first principal energy level that I've just drawn only has 1 sublevel. So the first principal energy level only having 1 sublevel would have S. The second principal energy level, so the next ring around the nucleus, has 2 sublevels, and they are S and P. The third would have 3, S, P, and D, and the fourth has all 4, S, P, D, and F. The same thing is true of the 5th, 6th, and 7th principal energy levels. So while it may be kind of difficult to remember all of those things, if you memorize this chart, you should be able to figure out everything else that you need to know. So some students in the past have made up mnemonic devices to remember the order of the sublevels. I like to say some people do fine in chemistry. I always hope it's most, but we're going to be honest here. Some people do fine in chemistry. The orbitals, if you look at the numbers, are just odd numbers. So starting with 1, then 3, 5, 7, and then because each orbital holds 2, you just double that number to get the number of electrons.